So this simulation capability, to describe what it is, first of all, it's a training and exercise tool that lets users create radiological simulations from the RadResponder website using an underlying source file or a preset template. And you can then view simulated readings for alpha, beta, and gamma radiation from the RadResponder mobile application. The latest version of this capability we're sharing with you today supports a range of features that were not available in RadResponder's previous beta simulator. So some of you might have been exposed in the past to a simulation capability we have had historically, but this is a new and improved version essentially that puts a lot more power and configuration in the end user's hands and really doesn't require much involvement at all from our support team. But some of those newly supported features include the things you see enumerated here: translocatable templates, open and closed window dose rate measurements, basic height dependent variations in measurement values, alpha and beta measurements, decay, and support for users to create custom simulations from modeling input files from NARAC and Rascal. There is also a beta version of a hotspot capability we're going to be making available. So again, all of these are features that were not available in the previous version of the simulator. Again, that some of you might have seen in the past. There's a lot of content here to cover and a lot of different facets of the capability that we could hit on. So just to establish up front the scope for this webinar, at least the presentation portion here, this webinar and the slide deck primarily focus on navigating the user interface and providing some basic explanations for the functionalities of RadResponder simulation capability. If you want more robust explanations for the scientific approach and guidance on creating custom simulations, that is available in the simulation manual in the RadResponder resource library. And there's also a quick link to that simulation manual you're going to see right in the simulation setup wizard. So it's right available there for you. That said, I think we will have some Q&A and some discussion after the presentation here. So if you do want to dive in more depth into some of those topics, at a deeper level, we can do that in the Q&A portion. So these simulation features for the RadResponder website will go out in our 167 website release. So that's scheduled for the first week of August. So coming up very soon. So some of the things that the items I'm showing here today, you're actually not going to see in the production version of the site just yet. But again, they're going to be released quite soon in the next couple of weeks. First week of August is our target for that 167 version that will make available all of the simulation features you're seeing here. The mobile application features are available in the latest beta version of the RadResponder mobile app. They'll also be available, of course, in the public release of the RadResponder mobile application. That would be version 1.0, which is scheduled for August 2021. And that mobile application will be available for iOS, Android, and Windows platforms. So if you've used the RadResponder mobile application in the past, and you're not familiar with what I'm describing in the RadResponder application, we were tasked by the FEMA CBRN office this year to create basically a consolidated RadResponder mobile app that combines both what the RadResponder application offers with the ChemResponder mobile application and the forthcoming BioResponder piece as well. So that mobile app, again, that'll be available in the month of August with all of these simulation features that you're going to be seeing here today. So simulations, first of all, are created and managed on the RadResponder website. And your simulated readings can then be viewed on the RadResponder mobile application. So just to clarify that up front, RadResponder is, of course, a web-based platform. So it's radresponder.net that you navigate to do things like create your events, manage your organization, all of those types of things. That's also where you will create and manage the simulations. And then, as you're going to see here, the mobile application is where you will actually view the simulated readings. To hit this one more time, the new simulation features are only going to be available in the RadResponder app, not the existing RadResponder mobile app. So that's an important point as well. Again, if you are an existing user of the RadResponder mobile application, even after August, when everything's fully released and out there, these new sim features will only be available on the RadResponder app. So that's hopefully some impetus to download the new CBRN Responder application, again, when it is available. There are these simulation features, but there's also much more that'll be at your disposal, and we're very excited about the forthcoming release. So you'll see other features on there that I think users are really going to appreciate and be excited about, in addition to these simulation capabilities. That said, there is a beta version of the CBRN Responder app out already, and it has been for some months. So if you would like information about how to access the beta version, you can shoot us an email, support@radresponder.net, and we'll get you some information about how to get that beta version. So I'll first provide a bit of an overview about how we get started with creating simulations in RadResponder. And I'll start by laying out the two different high-level methods for how we create simulations. And the first one is using what we call templates. And so as you'll see with a template, there's no source file that's required. And so users don't need to supply any external files at all. Rather, you're just going to be able to select from 5 preset templated scenarios. So you'll see there is a large and small nuclear power plant scenarios, simple and complex RDD scenarios, and then a nuclear detonation scenario as well. So it's a very simple setup process if you're using a template. As you're going to see here today, you're only really supplying the location, the wind direction, selecting your scenario, and the time window in which you want the simulation to occur. The second option is to create a custom simulation. And so with custom, you are supplying a source file from a modeling software like from NAMRAC or Rascal. Again, I mentioned there's a beta version of a hotspot capability we're making too. But you do need to supply that as an input file to create a custom simulation. The advantage here is the customization piece, of course. So you're going to have lots of options at your disposal for handling decay, the radiation types you want to support, what we call geographic interpolation, which we'll talk more about. Within an event, only users with the event manager role can create simulations from either templates or source files. So that's a critical point to see these functionalities that I'll be showing here today within your event. You do need the event manager role. So we'll start to look at some of the interface here and how we actually go about setting up these simulations. So within your event, you're going to navigate to simulations. So this is going to be an option that'll be under the configuration menu on the side navigation within the event space. In the upper right corner, you'll see a create button, and you'll start by clicking that create button. You'll see a multi-step wizard that's going to guide you through the simulation creation process. Again, you're going to see the simulation manual, quick link there, where you can download that. It's a Word document that provides robust explanations of the functionality, but also the scientific approach for the capability. So that's at your disposal. For this first step in the wizard, you're first going to choose a create mode. So as you can see, there are 3 different options here. Again, we'll create a simulation either from a template or from a source file. You can also load an existing simulation. I'll touch on scenarios where you might have a pre-existing what we call XSIM file that you'd want to load onto an event. But we'll primarily focus on creating from templates and from source files, of course. You'll select whether this will be the active simulation on the event once you save it. You can have only 1 simulation active on an event at a time. You could choose to add multiple simulations to a single event if you desire to, but only 1 of them can be active at a given time. From this screen, you'll also choose the input mode that will determine how mobile application users will supply simulated reading values on the CBRN Responder mobile app. So we've got descriptions there for each of these 3 options that you'll be able to see just by clicking that help icon next to the input mode. But there's a manual entry, automatic, and responder's choice option. Our recommendation is the manual entry. Essentially, users are forced to manually enter the reading that they're seeing. So they'll be presented in the interface with their simulated reading. They have to go in and manually enter it into the survey form. We recommend that because it's more consistent with a realistic training scenario or real-world operation. Users, of course, would typically be manually entering their readings. But there is an automatic entry option where that simulated value will just automatically populate into the survey form, or you could give them the choice whether they wanted to use the automatic entry option or manual entry, and they can make their decision at the mobile app level, the user can. So we'll talk more specifically about how we create a simulation using one of these templates. So on this step one, of course, I first select from my create mode that I want to create a new simulation from a template. So that's my first selection here. I'll then click next in the lower right corner there of the screenshot. You see we have a button to navigate to the next step of the wizard. You're brought to step two. You'll first select the template scenario you want to use. So like I mentioned before, there are going to be 5 different options here: a complex and a simple RDD, and then a large and small MPP scenario, and then a nuclear detonation template as well. So I'll make one of these selections. If we, of course, provide descriptions, as you can see in the table, for each of these scenarios. If you'd like some more details about each simulation template, including the compositions of the mixes, that information is available in the simulation manual. I'll next choose a simulation start and end date time. So this is the time window in which users will be able to see the simulated readings on the mobile application. So pretty straightforward there. Outside of that time window, they just won't see simulated readings. I'll next choose the wind direction. A note here to be mindful that wind direction is reported by the direction from which it originates. So for example, if I selected north, that would simulate wind blowing from the north in a southerly direction. And as you can see here, that's also elaborated on next to the, by clicking that help icon next to wind direction, we provide that information there. I'll next choose a location. So this is where the release of the radiological material is occurring. So if a nuclear power plant incident, it's the location of where the leak is occurring from the plant. So I just use one of my location entry modes to make my selection. So here again at the very top of the page here, we made our template selection, but then you can see the other options I just talked about here: our simulation window, our wind direction, and our location. So that's it really in terms of setting up your parameters for this template. And then I'll advance to next in the wizard. And step 3 is just a confirmation page here. So you can use the wizard user interface there to go back to a previous step if you want to change anything about your configuration here. Otherwise, I can just click Save Simulation in the lower right. I'm presented with a confirmation message that my simulation has been set up and saved successfully. If there are any warning messages, they would appear here. But as you can see here, quite a simple process to create a simulation from a template, really just a point and click method. So we'll talk now about how we create custom simulations. Again, the advantage here is custom simulations are going to offer a lot more customization and configurability. So it is a bit more involved than setting up a template. But again, a lot more that you as a user, as a planner, have control over. So like we said at the outset, creating custom simulations requires the upload of a source file from either NARAC or Rascal. And again, there's going to be a forthcoming beta capability for Hotspot. Custom simulations allow you to configure decay, radiation types, time and geographic interpolation, and your background values. So again, this allows users more configurability. It is a bit more effort, but you get, again, more control over what's happening with the simulation. So to get started, again, in our step 1, we choose create new from source files instead of our create new from template here. And when I select that option, you're going to see there's another step that pops into the wizard that displays at the top there. So we'll now have a step where we're going to upload our actual source file. So we go to step 2. And first, we're going to pick our source file type. So if this is NARAC or Rascal, select one of those options. In this example, first I'm just going to talk about NARAC. We'll talk about Rascal as well. But to discuss NARAC first, you can see that we've selected NARAC as our source file type option. We'll provide time zone, simulation start, end and date and time, and a release start and end date and time. So again, that simulation start and end date time, the simulation window, as we sometimes call it, same concept as with templates. So this refers to when the users will begin to see simulated readings on the mobile application. So outside of that window, again, they just won't see any of the simulated readings. The release start and end date time refers to when the release of radioactive materials starts and stops. So for a nuclear power plant incident, for instance, the release start date time would refer to when the release of the radioactive materials from the plant began. And of course, the end time would be when that release was stopped. We'll then be able to choose whether decay will be supported in the simulation. If yes is the answer to that you want to support decay, you'll then choose whether the simulation will interpolate between time steps in the source file. And that's what that include value interpolation between time steps refers to. So I'll elaborate on this a bit, what we mean by interpolation between time steps. So if you decide that no, you will not interpolate between time steps, so we set this option to no, the simulation will show a constant non-decaying value for each given time step in the file. So that file consists, like the graph is attempting to show here, that the file will consist of various time steps. And so in this example, between time 1 and time 2, again, that user will see just a constant non-decaying simulated value. Contrast that from turning this to yes, where we are going to interpolate between time steps. The simulation will linearly interpolate between the source file's time steps to gradually decay the simulated readings, rather than jumping, so to speak, from one time step to the next. So again, as the graph is depicting there, users will see a gradually decaying simulated value rather than those time step jumps that they would otherwise see. You'll then choose whether randomization will be enabled. When randomization is on, the simulated readings will fluctuate by 5% above and below the value, the true value, so to speak, from the model to mimic the behavior of actual detection equipment. So in general, this is something that we'd recommend, just given that, again, it would be a more realistic portrayal of what a user might be seeing from actual detection equipment. So that's all that randomization feature is designed to accomplish, is just to provide a more realistic experience for that user who's viewing simulated readings. You'll then choose whether the simulation will include only exposure rates. In other words, will users only be able to take gamma readings in the mobile application, or if multiple radiation types will be supported, in which case users could also take measurements for alpha and beta. Whichever radiation types you select to support for the simulation, you'll then be asked to supply background values for each of those types. So in this example, we've selected gamma, alpha, and beta for our simulation. So we'll be asked to supply background values for each of those. We'll talk a bit about RASCL. So rather than selecting NARAC, let's say we select RASCL as our source file type. I'll be asked some more things in the wizard here than with my NARAC selection, as you'll see. So we'll be asked to supply the release point location, whether we want to decay the model after 96 hours, and whether you want to support geographic interpolation. So we'll talk about each of those. So geographic interpolation, again, this will be one of the prompts that you're presented with if I select RASCL and I have the option to toggle this between yes and no. So for NARAC files, geographic interpolation is automatically enabled. But again, you've got the option here with RASCL. And what you're seeing on the left side is an illustration where geographic interpolation is turned on. And so what's occurring is we are, so to speak, smoothing the values between the polygons that comprise the RASCL model. So contrast that from the image on the right side. What I'm showing there is geographic interpolation is turned off. So effectively, users who are in one of these polygons, looking at their mobile application, seeing simulated values, when they walk or drive into another polygon, a neighboring polygon, their simulated reading value will jump, so to speak, to that next set of values, and they would see that same common value if they remain within that polygon. So again, the geographic interpolation, it's sort of a similar function to what's going on with the time step interpolation, but just again for smoothing for those polygons within the model. For RASCL models, you'll also be able to choose whether you want to decay the model past 96 hours. So those of you who might be familiar with the RASCL software will probably know that the software only supports time steps out to 96 hours. But we wanted to be able to provide users the option to continue to decay the model after a 96-hour period if they so chose. And so you can choose to set this option to yes, in which case RadResponder will use its equation-based decay feature, which we'll talk about next. So if I set this option, again, for post 96-hour decay to yes, the wizard will then present me with another field where it'll ask me to choose the mixture decay equation type. And I'll have two options to use either a polynomial or an exponential equation. I'll make my selection here, again, choosing polynomial or exponential, and a table will appear at the bottom of the wizard. And this is where I can add terms for my equation. So on the far right side of that table, you'll see an add term button. I click that and I'm given a modal where I'll enter coefficients and exponents. I'm not going to go into depth on how you find those coefficients and exponents, but the simulation manual offers quite detailed guidance about how to find those terms that you can then add into the table here for your equation. For RASCL models, like we said, you'll also be asked to provide location for the release. So I'll just use my location entry mode to provide that. And then we're going to be ready at this point to advance to the next step in the wizard. So this will be step 3, where we upload our source files. So the interface here is quite straightforward. I'm obviously just choosing the file that I'm uploading. In terms of what specifically you need to upload for NARAC or RASCL, again, there's some more detailed guidance in the simulation manual, but I will just touch on this a little bit. So for NARAC files, you need to upload a zip file with the following runs inside the folder. That'll be a dose rate, skin dose rate, alpha activity, beta activity, and total activity NetCDF files. So those 5 need to be included in the zip file that you'll upload. Again, those are provided as part of NARAC standard package if you request a model from NARAC. For Rascal files, users are going to need to upload a zipped version of the std temp file that Rascal outputs when models are run. So the file should look like stdtemp.zip, and that's what you'll upload into the interface. Again, we're providing more detailed instructions and guidance about that in the simulation manual. To load an existing simulation, pretty straightforward here. After I've created a simulation, either from a template or using the custom option, on the details screen for that simulation, you'll see the file itself. And so in this case, I have my complex RDD test 2.3.xsim. That's my simulation file. So you can download any .xsim file after creating a simulation from a template or creating from custom, and you could then upload that to a different event if desired. And so to go back to our wizard to step 1, if I were to select this load existing simulation option, I could then again upload the .xsim file that I got earlier and upload that here. The wizard obviously is quite simple in this case. I'm just providing the file, selecting the input mode, and then I'll continue through to the next steps for confirmation. Viewing simulated readings on the mobile application. So now that we talked a bit about how we set up simulations from the website, how do we view those simulated readings down on the mobile application? What are users seeing when they're interacting with the RadResponder mobile app? So again, just a quick reminder, the simulation features will be available in view 1 of the RadResponder mobile app. That'll be coming out in August 2021. We're starting to prepare the process for releasing the mobile app to all of the stores, Apple, Windows, and Android. So definitely encourage you. Obviously, we're going to be disseminating that information once it's available for everybody. You'll see communications from us to that effect. So first of all, simulations apply to specific events, as we saw. So I go into my event and I create my simulation from the event. So our first step on the mobile app is, of course, going to be navigating to the event we want. So I'm going to go to select event from my home screen. I'm going to go find the event that I want to use. Once I've clicked into the event I'm going to be using, on the event homepage, I'm going to navigate to configuration. And I'm going to open the simulations drop-down menu, and I'm going to download the simulation file. So you'll see in this drop-down, I can see the name of the file and when it starts and ends, and download that sim there. Once I've downloaded that file, the interface here will change to remove simulation file message. So that's just a nice confirmation that your file was successfully downloaded. Back on the event homepage, I'm now going to go to submit data, and I'm going to click on the surveys tile to open a blank survey form. And on that survey form, you'll notice the simulation mode active banner message at the top. This message is only going to appear when an event has an active simulation that has been downloaded to the device. So otherwise I won't see that message. So here, when we first navigate into the form, it's going to show a warning message that no simulated reading is initially detected because equipment has not been selected and the measurement height has not been entered. So we need to make some of those selections for the simulation to return a value to us. So to get a simulated value on the survey form, there are a few things we're going to do. We're first going to select a type. What's the type of radiation that we're measuring for? Is it alpha, beta, or gamma? I need to select equipment. And I need to select equipment with an efficiency that matches the radiation type you're trying to get a reading for. So if I'm going to get a simulated reading for alpha, then I need to make an equipment selection that has an alpha efficiency configured on it. And I'm going to talk a bit about how you can add efficiencies to your equipment. For alpha and beta readings, the equipment I select needs to also include a surface area. So again, I will also touch here a bit on how you can add surface areas to your equipment in RadResponder. I'll then enter a height for the measurement. And then I'll provide a location. This is automatically selected if I'm using the current location mode, and a date and time. Again, that's automatically selected to be the current date time, but you could modify either location or the date and time if you wanted to. But those are the parameters that are basically being passed into the code in order to give you back a simulated reading. So I'm going to pop back to the website here for a second to briefly show you where you can view and configure some of those pieces you need to be able to get simulated readings back. So efficiencies and surface areas, namely. In the organization space, which you can see I'm selected into here, I'm at the equipment page in the organization space, and I'm going to navigate into details for one of my instruments by clicking that little magnifying glass that you see on the table on the left side. And when I do that, I'm going to be able to scroll down to a default efficiencies table at the details page. And on the right side, there will be a manage button. And that's where I can go in and add efficiencies to the instrument. Very simple interface. I just choose alpha, beta, gamma, and I can supply an efficiency for each of those radiation types there. To configure my surface areas, again, I'm still at obviously my same equipment page in my organization space. I'm going into the details form for the instrument, and I'm going to click edit for that instrument. And then when you scroll down, you're going to see an equipment details section, and there will be a surface area field there where I can supply a surface area for this probe. Now, obviously, it's important if you're using simulation to kind of be able to track what's going on with your efficiencies within an event. So one thing that we've added relatively recently is a sort of global efficiencies view for all your instruments within an event. So here I'm actually in the event space rather than the organization space. And in the event space, on the side navigation, I've got an equipment drop down. And when you open that equipment menu, there is an efficiencies menu. And so when I click into this, I'll see a page that says event equipment efficiencies. This table comprehensively shows all my instruments with the efficiencies that are populated on those instruments. So this is kind of a nice holistic view to quickly be able to see what the efficiencies are for all of your instruments within the event. So within any event with an active simulation, there is also simulation equipment that is available if you do not want to use your own organization's equipment, or you have not properly configured efficiencies and surface areas for your organization's equipment. So we're definitely sensitive to the fact that some organizations might not yet have taken the time to go in and configure their instrumentation in their organization space. We don't want to leave you kind of dead in the water if you haven't done that. So there is a very simple option at your disposal here to use instead the simulation equipment. So what I'm showing here on the survey form on the left side screenshot, you'll see I'm selecting into the meter field. And so this is going to present me a list of the organization equipment that I can select from. But again, if we know that, hey, we haven't set up efficiencies or surface areas for these, I'm just going to instead use the simulation equipment option. And so this is a filter that I can select at the top of the page there. And so I'll just click Show Simulation Equipment. And when that filter is on, I'm going to see a simulation meter that displays for me. So I'm going to select that meter. And then once I select it, I'll see back on my survey form that in the meter field, the simulation player selection has populated. Now I want to select a probe. And so I'm going to select into the probe menu. Having selected this simulation meter, that probe list is automatically going to filter down to simulation probes that have been assigned to this meter. So I'm going to go ahead and make one of those selections. You can see here it's quite simple. I've got an alpha probe, a beta probe, and a dose rate probe. So depending on what radiation type I'm measuring for, I'll make one of those selections. This table in the lower left shows the efficiencies and surface areas we're using for simulated equipment. So you can see the alpha probe has an alpha efficiency of 30%, a surface area of 100 centimeters squared. The beta probe, a beta efficiency of 20%, surface area of 15.5 centimeters squared. And the dose rate probe has 100% gamma efficiency. Surface area does not apply. So back on our survey form here, we'll just confirm that our selections were made here for our meter and probe simulated equipment we're using in this case. And now we're going to be ready to take a beta measurement. So in this final section here, I want to touch on the data generator. So the data generator is an option you're going to see at the simulation menu. Again, if you're an event manager in the event, you'll see this user interface. So it's right next to the create button. I see a run data generator option. The data generator lets me generate simulated values in bulk, so to speak, using a spreadsheet. So this could be useful in exercises as a key for the readings players should be entering, should be seeing. It could also be used as a testing tool. So I can get started here by first selecting the simulation you want to generate data for. So the list here shows all simulations that are on this event, whether or not they're active. I'll go in and make a selection. So here I've chosen my large MPP test 2.1 simulation. I'll then download the template file. So the template file is just a CSV with columns where you're going to enter the parameters for the readings you want to generate. So it's pretty straightforward. In this example, I'm just entering 3 gamma measurements. I'm taking those at 1 meter waist height. The efficiencies and heights, again, those are going to be required. Our surface area is going to be required for alpha and beta measurements. So I'm just going to go into this table and populate in lat longs. For this altitude field, that's something that we basically couldn't leave out. I know it doesn't really pertain in this case, but for kind of some back-end reasons, you need to supply an altitude. So that can just be 0 though. This pertains to our mobile surveys data type and some things that we do with UAVs. But so just supply 0 for that altitude though. Supply your height in meters. So again, in this case, we'll supply 1 meter. Supply and date and time for my timestamp. Again, we'll do 3 gamma readings. For the window, open or closed, if you leave that blank, namely for your alpha and beta measurements, this is going to default to a value of true. It's going to assume that you're going to take an open window measurement. So fill out those fields, and then we will upload our template into the interface. And then when we run the generator, it's going to spit out another CSV for me. And this time, there's going to be values that are populated for the rows that I've supplied in the data generator. And so this resulting CSV will look like you see here with values in units. So that brings us to the end of the session here. I know that was a lot of ground to cover, and there's plenty more we can talk about.